In our last few videos, we've looked at several different methods of solving quadratic equations, and we've created kind of a flow chart, a thought process on how to best solve a quadratic equation. If you have questions about this flow chart, go ahead and rewatch those previous videos. What we're going to look at in this video is solving equations that at first don't look like quadratic equations, but then we're going to see that we can use quadratic methods to solve them. Let's say that we're looking at an equation and we're being asked to solve. And remember, solve means find the value or values of x, that if you plug that number back into the equation in place of x, you would get a true statement, a true equation. So let's say that we have this equation, negative 15x cubed plus 5x squared is equal to negative 20x. This is not a quadratic equation because it has a cube instead of the highest term being squared. So this is actually a cubic equation. So when we solve this, we should be expecting 3 solutions because the highest order is 3. But we're going to see if we follow our first few steps from this flow chart. We're not going to worry about the no bx term. We can't isolate the x squared because there's x cubes and x squareds and x's. So we're going to start here with getting equal to 0, and instead of keeping the ax squared term positive, we're going to keep the highest term positive, the x cubed term positive. Then we're going to divide out any common numbers and cancel those out, and then we're going to factor any common variables. And remember that you have to keep that x as part of the equation. You cannot divide and cancel that one. So I'd like you to go ahead and do those steps on this equation. Pause the video, do those steps, and then turn the video back on. Okay, so we see that we want to keep our highest term positive. And because we have a minus sign here, we're going to move everything on the left over to the right. So we'll have 0 equals positive 15x cubed minus 5x squared. And then the negative 20 was already on that side, so it stays negative 20. Our signs change as they come across the equal sign. Then we look for any common numbers. We have a 15, a 5, and a 20. All of those are divisible by 5, so we can divide out a 5. 0 divided by 5 is still 0. So the 5 divides out and cancels. Now we look for any common variables, and notice that every single term here has an x in it. So we can actually factor out an x. And we have to keep that x. We cannot divide by x and cancel. We have to keep it as part of the equation. So dividing each term by x, that's what we end up with. And notice that we have here now a quadratic equation. So we can use quadratic methods to solve that part of the equation. And remember that our first way that we try to solve a quadratic equation, if we have that middle term, is to try to factor it. So let's do that. I'd like you to try to factor the quadratic part. And notice the x comes down, it's still a factor, and then we have 2 more factors. So you can either use the guess and check method or the AC method because we have this 3 here. So spend a few minutes, pause the video, spend a few minutes, factor that quadratic, and then restart the video. Okay, I'm going to use the guess and check method. And because I have a 3x squared, I know I have to have 3x and x. That's the only way that I can multiply and get 3x squared. And then I have a minus 4, so that tells me that I either have to have 2 times 2 or 1 times 4, one term positive, one term negative to give me the minus sign. So I can have plus 2, minus 2, or I could have minus 2, plus 2. Or I could have a 1 and a 4 with one positive and one negative, or the other way around. Or I could flip-flop the 1 and the 4 with a positive and a negative, or the other way around with a negative and a positive. Notice I had to switch the 1 and the 4 here and here. These are different factors. When I had the 2, if I flip-flop the 2's, then it's still the same thing, so I didn't have to do it there. Now, these are all the possible ways that I could get the 3x squared and the minus 4. But what I'm interested in figuring out for the correct factorization is which one gives me the minus x in the middle. If I do my outer and inner on each of these, which one gives me a negative x as my x term? And that will be the correct factorization. So if you haven't done this already, go ahead and double check that and figure out which one is the correct factorization. Pause the video, try that, and then start the video. All right, so I see that for this one, multiplying 3x times negative 2 and 2x is negative 4x. And if I switch my signs here, notice what happens if I switch my signs. I'm going to get positive 6x minus 2x is positive 4x. So switching the sign changes the sign here, but it doesn't change the number. So neither of those work. Then let's try this one. Minus 12x plus x is negative 11x. So I knew this one would give me 11x, so neither of those work. Then I tried this one. Minus 3x plus 4x is x. So I have the right coefficient, but the wrong sign. So that tells me that this one is going to be the one that works. So I can rewrite that factorization. 3x minus 4, x plus 1. And as we practice the guess and check method, we can do some of this math mentally, and we can kind of get a feel for getting to the correct answer more quickly. All right, back to the original problem here. We have now factored this. And notice that I started out with x cubed. I have 3 factors. And remember, factor means what I multiply together to get the original polynomial. If I multiplied x times 3x minus 4 times x plus 1, it would equal this polynomial. And just the way we did when we had 2 factors, we set each factor equal to 0 and solve for x. Do not forget that this x is one of my factors, so I set it equal to 0, and I get a solution that x equals 0. And if I look back at the original equation, I see if I put a 0 here, here, and here, I would have 0 equals 0, and that is a solution. Then I can solve this one for x, and I can solve this one for x. And I end up with 3 different solutions as I expected because of the x cubed. So on this problem, once we divided out that variable, we ended up with the quadratic, and we could use quadratic methods to continue to solve. Let's look at another example. On this example, let's say that we are going to solve, and our equation looks like this. So we're going to follow our first few steps where we get the equal to 0, keeping the highest term positive. We already have that here. Then we look for common numbers to divide out, and we see that we don't have any. Then we look for common variables to divide out, and we see that we don't have any because there's no x's here. So now we're ready to move forward with using other methods. At first glance, this does not look like a quadratic because of the exponent 4. This is actually what's called a quadratic equation, and we're going to end up with 4 solutions. But we're going to see, because of the pattern of this equation, that we can actually use quadratic methods. So leave some space underneath that equation and drop down in your notes and actually solve this equation. And I'm going to do this with a different letter because I don't want to confuse with the same letter. So let's say that we have u squared plus u minus 20. And I want you to go ahead and solve this equation. Pause the video, solve this equation for u, and then start the video back up. And hopefully you saw that this was a relatively simple factorization. The only way to get u squared is u times u. And then, because we have an understood 1 here, we can think of two numbers that multiply to give me negative 20 and add to give me 1, which are going to be plus 5 and minus 4. So if I set each of these equal to 0, I get u equals negative 5 and u equals, skipped a step here. Let me go ahead and write that step. U equals 4. All right, so we had a factorization there, u plus 5 times u minus 4. What does that have to do with this problem up here? Notice that my numbers, my coefficients, the 1 and the plus 1 and the minus 20 are the same here. And notice that if I multiply x squared times x squared, I get x to the 4th power. So I can actually factor this. And instead of putting a u or an x, I'm going to have x squared times x squared. And then the part that gives me the negative 20 is going to be the same. It's going to be the plus 5 and the minus 4. If I FOIL this back out again, I would have x to the 4th minus 4x squared plus 5x squared minus 20. Combine my middle terms, and I see that I do have a correct factorization. So I can let x squared replace the u in this equation. And notice now that I have two separate factors here. X squared plus 5 has to equal 0, or x squared minus 4 has to equal 0. And even though I still have an x squared in there, this process still works. And now I can go back to my very beginning process here. If there is no bx term, the easiest way to solve a quadratic equation, which both of these are, two separate quadratic equations, is by isolating the x squared and then taking the plus or minus square root of each side. Go ahead and pause the video and find our 4 separate solutions, and then turn the video back on to check. So solving this one, if I subtract 5 from both sides, I get x squared equals -5, and then I take the plus or minus square root of x squared is x, plus or minus square root of -5. This negative and this plus minus don't affect each other. You can't go through that radical. And remember that I is the same thing as the square root of -1. So rather than leaving this negative here, we're going to call this I times the square root of 5. And then I want to write that as 2 separate answers. So -I square root of 5 and I square root of 5. And then I can do the same thing with this one, bringing the 4 across. That one's positive. So I have plus or minus square root of 4. And this one simplifies. Over here, I couldn't simplify. 5 is prime. There are no perfect squares, so I have to leave it as an exact answer with the square root of 5. But the square root of 4 is a perfect square. So I can actually do the square root of 4, which is 2. And I get my other 2 answers, -2 and 2. So this is my 4 answers that I was expecting, 4 solutions that I was expecting, because we had to the 4th power. So this is what's called a quadratic type. At first, it doesn't look quadratic because the highest degree is not a 2, but then we see that it does actually factor in a similar way to a quadratic, and then we solve the resulting factors set equal to 0 using linear or quadratic methods.